using the prime factors to find the LCM. And to find the LCM using the prime factors, we have to follow a set of rules. We recall that in the previous lesson, we find it difficult finding the LCM by just writing out the common factors. So an easier way is to use the prime factors to do that. However, to use the prime factors, we have to follow a certain set of rules, and that is what this video is about. So what are the rules? These are all of it. They are not difficult, and they will come in handy as you practice them on and on. Alright, so the first is to write the prime factors of all the numbers present. So if you have two numbers, you reduce them to their prime factors form. Again, there is a video on that, so make sure you check that one out if you haven't already. Then after you've written the prime factors, you have to identify all the different prime numbers in the prime factors you found. Then you have to choose all the different the prime numbers with the highest index. Usually if you reduce numbers to prime factors, you see that they have indices or power. So the one with the highest one, we go with it, and then finally we multiply these different prime numbers with the highest index. So let's see how we can actually put that to practice. This was the question we were to do with the previous video, which we couldn't find because it was getting lengthy. So how do we use the prime factors to find the LCM for 6, 8, and 10? Like the rule says, first write the prime factors for all the numbers present. So when we take 6, we write down its prime factors. It is 2 and 3, 2, 3, 6. They are both prime numbers, so we can't reduce it any further. Now, this is how we represent it in the index form. It is 2 to the power 1 times 3 to the power 1. But since it is just 1, we omit it. If it were to be 2 or 3 or any other number besides 1, we would have written it. Great. So this is it. The prime factors of 6 is 2 times 3. How about 8? We reduce it. It is 2 and 4, and then 4 2 becomes 2 and 2. Writing it in the index form, it is 2 to the power 3. 2 times 2 times 2. 2 to the power 3. Okay. The same way, we get to 10. We reduce it to prime factors. It is 2 times 5, and they are both prime numbers. So that is it. That is the prime factors of 10. Now, the second rule was to identify all the different prime numbers we have. How many different prime numbers do we have here? We have 2, we have 3, we have 2, 2, and then 5. So we have 3 different prime numbers, 2, 3, and 5. We have 3 different prime numbers. Okay. Now with the different prime numbers, for each of it, we have to identify the one with the highest index. So when we take the 2's, we have 2 to the power 1 here, 2 to the power 3, and 2 to the power 1 here. We have to choose the one with the highest index, which in this case is 2 to the power 3. So we are going to choose this. When we come to 3, it appears just once, and then it's different. So we have to choose it. But then the highest power of it is also 1. So we keep that one aside. Then 5 2 appears just 1, and the highest power is 1. So at the end of the day, we are going to multiply 2 to the power 3 times 3 times 5. These are the different prime numbers, and these are the highest index of all of them. So 2 to the power 3, 3, and 5 is what you are going to multiply. And that is this. 2 to the power 3 times 3 times 5. 2 to the power 3 is basically 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8, times 3 times 5. 8 times 5 is 40. 40 times 3 is 120. This is the LCM of 8, 6, and 10 using the prime factors, which tells us that if we were to list the factors, then we would have to find the 20th multiple of 6 and the 15th multiple of 8. and then the 12 multiple of 10 before we could have found this, which is cumbersome. But then by using the prime factors, we simply find it this way. Let's see, how about using the same method we've learned to find the LCM for 3, 12, and 15. Pause the video, give it a try, and then let's see. Okay, so the first thing is to write the common factors. The prime factors. So when you take 9, it is 3 and then 3. That's it. They are both prime numbers. So we've done the prime factorization for that. 3 times 3 or 3 squared. Great. When you take 12, 2 and then 6, then 6 is 2 and then 3. So writing it in the index form, it is 2 to the power 2, 2 times 2. So 2 to the power 2 times 3. We take 15, it is 3 and then 5. That's it. They are both prime numbers. We can't reduce it any further. Alright. After doing this, what are the different prime numbers we have? Again, we have 3, 2, and then 5. They are the different prime numbers. Now we have to choose each prime number, and then with each one, the one with the highest power. Here 2 appears just once, then the highest power of it is 2 to the power 2. 3 appears 3 times. We have it here, here, and then here as well. But then the one with the highest power is this. So we are going to stick with this. 5 appears just once, and then its highest power is 1, which tells us we are going to multiply 2 to the power 2, 3 to the power 2, and then 5. When we do that, this is it. 2 to the power 2 is 2 times 2. 2 times 2 is 4. 3 to the power 2 is 3 times 3. 3 times 3 is 9. Then 5. 4 times 5 times 9 is 180. 4, 5, 20. 20 times 9 is 180. So this is the LCM for these 3 numbers, which would have been very difficult to come by if we were to list the common factors. So this is how we use the prime factors to find the LCM. Make sure you like, you comment, you share the video as you gain value from it. Alright, check the next videos out.